Jai Gurudev, good morning, student. Today we'll take first of all we'll take the ideal gas equation. First of all, what is ideal gas? A gas which obeys your Boyle's law, Charles law, Avogadro's law. Boyle's law, Charles law, Avogadro's law is called ideal gas. Now from that ideal gas, we first of all finding the ideal gas equation. From Boyle's law, V inversely proportional to pressure at constant temperature in N. From Charles' law, V directly proportional to temperature at constant pressure in N. From Avogadro's law, V directly proportional to N at constant pressure and temperature. We consider this one is equation number 1, this is 2 and this is 3. Then on combining equation 1, 2, 3 we get combining equation 1, 2 and 3. V is common, varies to T and by P. Now this varies sign, you have to remove that varies sign by a constant. So V equals to R and T by P, where R is universal gas constant, or which implies Pv equal to nRT. So this equation you have to remember, Pv equal to nRT, or as R is the universal gas constant. So from above equation, what you are getting? From above equation, R equal to Pv by Nt. The different units of R that you have to remember. R equal to 0.0821 atm liter per mole per Kelvin. R equal to 0.0831 bar dm cube per mole per Kelvin. R equal to 8.314 joule per Kelvin per mole. So these are 3 units of R that you have to remember. Generally, for pressure related things, we have to use the 1 and 2, and for energy we have to use this one. This one is only for energy. If any question energy related things, then you have to use this one. Then we have next is your combined gas equation. Next, combined gas equation. Same PB equal to nRT. So PB by T equal to nR. Now for a fixed number of moles, and R is always a constant, so this become a constant. So therefore what you can write, E1 V1 by T1 is equal to P2 B2 by T2. This equation is called combined gas equation. Next we're going to read another point. This is aqueous tension. Now gases generally collect in this manner. Now if you have a gas, there a jar is there, there is water is there. Now gas you collect like that. When the gas collect in the jar, the it is just like that when people comes out from the swimming pool, there is some water stuck to their body. When the gases collected in a jar by downward displacement of water, some water particles stuck to the body of those gases. So pressure we have considered, this is total pressure of that gas plus water. Now pressure of dry gas is equal to total pressure minus the pressure of those water particles. This is aqueous tension. So pressure of dry gas equal to total pressure minus aqueous tension. That part you remember. So next point is your student, you have Dalton's partial pressure. Dalton's law of partial pressure. So this states that the total pressure exerted by a mixture of non-reacting gases is equal to the sum of partial pressures of individual gases. For example, in a container, the total pressure exerted by gas A plus gas B is equal to P total. Then this P total pressure is equal to the sum of PA plus PB, partial pressures of A, partial pressure of B. This is what is called Dalton's law. Now we are going to establish a relation between total pressure and mole fraction. Total pressure and mole fraction. So let us consider three gases confined in a definite volume of that container V, and at definite temperature T. There is three gases. This is the gas A, this is gas B, this is gas C. This is A, this is B, this is C. gas having number of moles n1 and partial pressure is P1, gas B number of moles N2, partial pressure P2, gas C number of moles N3, partial pressure P3. Now we know PV equal to nRT. This is the common, or P equal to nRT by V. Since V and T are constants, R is also constant, the variable factor is N and P. Therefore, for A, P1 equal to N1 RT by V. For second gas, P2 equal to N2 RT by V. And for third gas, P3 is equal to N3 RT by V. If this consider equation 1, this is equation 2, this is equation 3. Now applying Dalton's law, what we have? P total equal to P1 plus P2 plus P3, which implies P1 plus P2 plus P3, which implies that N1 plus N2 plus N3 RT by V. This is equation 4. Now 4 divided by 1. 1 divided by 4 actually. 1 divided by 4. In 1 we have P1. In 4 we have PT. P1 by PT. This is we have N1 in 1 and